Hello, I'm Second Lieutenant of the Portuguese Army, Carlos Gomes, and today I'm pleased to present you, on behalf of my co-authors, a first exploration on the use of head-mounted augmented reality in the context of the Portuguese military. I'm going to start by talking about our introduction and related work regarding military augmented reality. Afterwards, I'll explain our systems architecture, interface design, and our user study. I'll finish the presentation talking about our limitations, future work, and conclusion. Augmented reality is an emerging computing platform that has been finding its way out of the lab and into a wide range of enterprise applications, such as healthcare, industry, and emergency response. This is particularly true of head-mounted augmented reality due to its wearable form factor, hands-free control when needed, and egocentric operation capable of displaying contextual information directly onto user surroundings. The latter is critical in tasks that demand high situational awareness that various examples exist that demonstrate the positive effects of augmented reality in this regard. These include augmented reality systems for security, driving, firefighting, crime scene investigation, remote collaboration, etc. Situational awareness, or the lack of situational awareness, in the military context has been linked to fratricide, which is the accidental injury or fatality of friendly forces. This has been established by British and American armed forces, while others have observed that diminished situational awareness can cause inefficient employment of forces and weapons on the ground. Augmented reality is a technological area of priority interest and part of the Portuguese military programmation law. Currently, the state of the art regarding military augmented reality are projects such as ARC-C4 and IVAS of the US Army. These are confidential projects that don't publicly share how to show the information nor which information to show. Therefore, there is a lack of publicly available information regarding military augmented reality. We did a user survey to 86 soldiers of the Portuguese Army, 58 of which had experience in international deployments. All ranks and all branches of the Portuguese Army participated in this survey. The survey reported the relevance of information, such as the position of units or weather. We found out that the most important facts are the position of enemy and friendly units, maps, and mission guidelines. In our survey, the soldiers reported an high experience with current Army systems and also reported little to no experience regarding augmented reality systems. They also reported the requirements of current systems and reported the causes leading to the reduction of situational awareness. From the information collected in the user survey, we designed the user interface with three main features: an always-on compass, an alerts menu, which is activated by looking to the palm of your hand, and a map, which is activated by a button in the UI. Here you can see screenshots of the three main features: the compass, the alerts menu, and the map. Our system's architecture is comprised of three main parts: a gateway, responsible for the translation between the current command and control system and our system; a terminal, where commander selects which soldier sees which information, which is useful to filter information; and a server, which is used as a database to send and receive information to the AR goggles. Our user study was designed to gather initial insights into our augmented reality interface. 13 soldiers from the Commando Regiment took part in the tests, and their participation was voluntary and anonymous. We started the study by designing a real-world scenario and evaluating each of the systems, the augmented reality system and the baseline, which is comprised by a radio, compass, and a map. Afterwards, we compared the results of both systems. As for the metrics, we used SUS to measure usability. We applied the Likert scale after the test. We used NASA TLX to measure mental workload and SART to measure situational awareness. Both these tests were applied after the test using Likert scales. We also measure the test duration during the test. The procedure of our user study was done in the following way. The participant does the tasks with the augmented reality system, swaps the system to the baseline, and does the same tasks and in the test. To explain this to the soldiers, we use real-life standard procedures like radio callouts and military tactics. We explained that their mission was to infiltrate, rescue an hostage, and exfiltrate from the site. The tasks were as following. Report a location, emit a medvac and accident report, indicate which way is west, and receive a unit location as well as reporting an enemy location. We observed an 25% higher reported usability when using the augmented reality system. We also observed a 34% lower physical demand, a 20% lower time demand, and a 31% lower effort. We observed a 29% lower complexity, a 38% higher information quality, but we also observed a 31% lower familiarity when using the augmented reality system. In the test duration, we did not find any statistically significant results. The reported usability of the augmented reality system was higher when compared to the baseline, due to its aggregation of tools such as map and a compass in a single system. The reported mental workload was lower when using the augmented reality use system. This was mainly caused by the use of a graphical user interface instead of textual information interface. A positive trend was found in the situational awareness, but it's not statistically significant, as can be said for the test duration. In our study, we didn't measure any health considerations, for example, nausea or eye strain. These problems were reported by American soldiers when using IVAS. Further objective metrics should be used, such as input precision, cognitive load, or gaze dwell times. Despite the use of representative stakeholders in the design and study of our system, a limitation is that all the participants belong to the same unit. Future iterations of our work should recruit a more varied group of stakeholders from several infantry regiments and from other branches of the armed forces. We didn't assess any hands-free or eye tracking, and our system has limited functionalities when compared to the current communication systems. As for our future work, we plan on adding more features to the system, participating in NATO exercises such as Sea Weeks, and test our augmented reality system with different NATO countries. As for our conclusions, our case study was the first in the Portuguese military, and explored XR opportunities. We use readily available hardware and software, such as HoloLens 2 and the Mixed Reality Toolkit. Our user study was done with representative stakeholders of the Portuguese Army and evaluated in the Portuguese Commando Regiment. We compared our systems with the current system in a field test and reported some benefits when compared to the baseline. Here you can see a footage of a soldier using the system. The compass, the alerts menu, him using the system, the map, where you can zoom in, zoom out, scroll around, open information about a specific unit, and the compass again. Thank you for your time.